Hello Gators, this is 5.4, using the first derivative test to determine relative or local extrema. 5.5, using the candidates test to determine absolute or global extrema. The first derivative test is when we use the first derivative to test whether or not a function has a max or a min. Let's start with something we know, like a quadratic function that opens up. Notice that our derivatives on the left side of the turning point are negative. The sign is negative. At the turning point, the derivative is 0, and afterwards the derivative is positive. So we say that something is a minimum. There is a minimum value at x equal to c because the sign of the first derivative changes from negative to positive. And likewise, if the parabola were going down, we would have a maximum value, and we would say that because the sign of f prime changes from positive to negative. Okay, let's use the first derivative test to find the x values of any relative extrema of this function. So I've taken the function and I have found the derivative, and here's the derivative. What we're looking for are our critical points. When does the derivative not exist? And the derivative does not exist when the denominator equals 0. So this is going to happen at x equal to 2 or negative 2. Then we want to look at what happens when another critical point is when f prime of x is equal to 0. And that happens when the numerator is equal to 0. And that's going to happen at x equal to 0. So these are the places that we want to look for what's happening. Right here we can now set up a chart. We've used the 3 points, negative 2, 0, and 2. And we're going to look at what happens before, in the middle, and afterwards. Here's my derivative. I'm going to pick a point in this between negative infinity and negative 2, which I picked negative 3. If I put negative 3 in the numerator of the derivative, I'm going to get a negative value. And if I put negative 3 in the denominator, I'm going to get a positive value. So this is going to be negative. In this region here, I'm going to pick a value somewhere in this interval, negative 1. If I put a negative 1 in the numerator, I'm going to get a negative. If I put a negative 1 in the denominator, I am going to get a negative in the cube root, which is okay, which is negative. So negative divided by negative is a positive. I'm going to test out a point in the next interval. I'm going to choose 1. The numerator will be positive. In the denominator, putting a 1 down here will make it negative, so I'll have a negative value. And then in this interval, I'll choose 3. I'll have a positive in the numerator. And in the denominator, if I put the number 3 here, I'll get a positive. So I have this. So I've determined what's happening in all my intervals. What this tells me is what's happening to the graph. The graph is, when it's negative, it's going down. It doesn't exist, and then it goes up, and then reaches a hill, and then goes down. I have it does not exist, and then it goes up here. So that's what the sign of the first derivative is telling me. So I can now say something about my the fact that I have a minimum value at x equal to negative 2 and 2 because f prime changes sign from negative to positive, and I have a maximum value at x equal to 0 because f prime changes sign from positive to negative. I provided the graph here, and you can see that it is a continuous function. It's just that there is no derivative at these points, negative 2 and 2. Let's take a look at something else. Let's find the derivative of h of x. And when I notice that I have found the derivative using the quotient rule, and I have simplified it to this point right here. The derivative does not exist when the denominator is 0. That's at 4. And another critical point is when the derivative is equal to 0, and that's when I'm looking at my numerator, and that's going to happen at 0 and 8. So these are numbers I want to look at. I'm going to set up my chart, and the number 4 that I'm using here does not exist, actually is not defined for the function. This isn't really a critical point at all because it's not even a point there. We just don't have a point there. So be careful. We're going to still put it in our chart, but understand it's not a critical point. All right, I'm going to go ahead and find the signs. I'm going to find a number in this interval, and a number in this interval could be like -1. And if I were to put a -1 here, I would have a negative here, and a -1 over here would be a positive. And then this part right here is always going to be a positive number, no matter what number I put in there. So a negative times a positive will be a negative. I'm going to put a number from 0 to 4. Say put the number 1 in there. So if I put the number 1 in for x, I have a 1. And if I put in, that's going to be a positive. And if I put the number 1 right in here, I am going to get 8 minus 1, which is going to be a positive number. And we know the denominator is positive anyway, so this will be a positive. I'm going to test out a number like 5. So 5 over here, that would be a positive. Put a 5 here, that would also be positive. And so the answer is going to be positive. Remember, the denominator is always negative. I'm going to test a number like 10. If I put 10 in here, I'm going to get a positive. Put a 10 over here, I'm going to get a negative product here, and so that answer will be negative. So this is kind of telling me what the graph is looking like. It's going down and then up. There's an undefined situation, and then I'm going up and then reach a plateau, and then I'm going down. So that's what I'm picturing going on. I'm going to make a decision, the minimum at x equal to 0, because f prime changes sign from negative to positive, and max at x equal to 8 because f prime changes sign from positive to negative. You need to put that justification in there. And I went ahead and gave you the graph so you could see that we did go down and then up and then up and then down. I do want to talk about these words. What is a maximum value versus where is a maximum value? Where is a max, and that's located right here. Where is the max is what they're asking is the x coordinate at x equal to 8. What is the max? What is the max is asking for the y coordinate, and that y coordinate will be negative 16. Okay, let's take a look at this picture, and this is a closed interval test. And in this closed interval, we are going to have an absolute max and an absolute min. Let's take a look at the graph and see what we have to do. This is an endpoint, and that is a candidate. And we also have a minimum here where the derivative is equal to 0. We also have a place here where the derivative does not exist. And we have another point here where the derivative is equal to 0. We have another one where the derivative is equal to 0. And we also have an endpoint here. So when we're looking for absolute maxes or mins, you look for critical points where the derivative equals 0 or does not exist, and at endpoints. One more time, the extreme value theorem states that there is, in a closed interval, there's an absolute max and a min, and the places that you're going to look for them are at critical numbers of the function and at the endpoints. You take a look at all those candidates, you figure out their y values, and then you make the choices of least and greatest. Let's go ahead and do a problem. Here we have a function, and this is a closed interval. We want to find the absolute min and absolute max. To do that, we're going to look at our critical points, which means take a look at the derivative and set the derivative equal to 0. There will be 2 points, 0 and 2. So here are 2 candidates right here. The other 2 candidates are our endpoints. So we're going to want to put -1/2 in here. We're going to want to put 0, 2, and 4. I'm just going in order. And I'll go ahead and put those in, and here are my values. And then I can go ahead and compare. I can see that this is the absolute min because it's the smallest y value, and this is the absolute max because it's the largest value. So by the candidates test, we have found the absolute max and the absolute min. And I have also provided the picture of the function so that you can see that we were able to find it. Let's take a look at this one. This one is yours. Please stop the screencast and then I will give you the answer. And here is the answer. I want you to notice that one of our critical points was 4, and notice that I did not even use 4 because 4 was not in the interval, so it wasn't a candidate at all. The only candidate was the 0 and the 2 endpoints. And so by that I was able to figure out the absolute max and the absolute min, and the verification is the graph. This is the end of the screencast.